All right. Hello, everyone, and welcome. If you are here because you're excited about the topic of securing root, then you are in the right place. My name is Erin Crow. I'm a principal product manager at AWS that focuses on account protection, where I've spent about 12 years in total at Amazon. And I have a wonderful co-presenter today.
Good morning, everyone. I'm Jason Garman, and I am a principal security solutions architect here at AWS. Been here about 2.5 years and very excited to share some great news with you about some new features. Thank you.
Thank you. All right. Thank you again. So sorry about that. So we have a packed agenda today. We're going to be talking first about secure by design, a history of AWS account access, the future of AWS root access, MFA at AWS, and the changing MFA requirements that we have upcoming. Okay, perfect. All right, we're back. So what do we mean when we talk about secure by design anyway? Well, we're actually talking about a set of principles and practices as well as an operational and mental model for developing security software and infrastructure that is secure right out of the box. It means treating security not only as a set of features, but ingraining it from design onward to launch and beyond to ensure that we're creating the right sets of defaults for our customers so that we're making it very easy for people to make good security decisions and harder to make poor ones. And at AWS, we've practiced secure by design from day one. We've ingrained this thinking throughout all levels of our organization. If you've been at other talks at re:Invent this week, you've probably heard someone say something like security is our top priority. But this is really not just a mantra for us. This is a practice that we hold each other accountable to from all levels of the organization and all stages of the life cycles that we manage. And you can see some examples of decisions that we've made over the years that put these principles into practice. For example, in our services, we don't use default posture or default passwords, instead provisioning them uniquely on a per user basis. We've increased our investment in memory safe languages such as Rust, which is used in the open source authorization policy language and authorization engine Cedar. And then we have a variety of features that are fundamentals for security that we make available at no additional cost, like multi-factor authentication and the newly launched resource control policies. But it's not enough to simply release a set of features and say, that's it, it's okay for good now because it was secure at the moment that we released it. With the changes in our world with digital transformation, the techniques that are used by malicious actors also change and evolve, which means that we need to constantly reevaluate what is the right security posture. We can and do make policy changes when it's necessary to help make sure that we're giving our customers the right posture. For example, in 2022, we changed the S3 default bucket policy to block public access by default. And we did this again when we launched Amazon DynamoDB resource-based policies, which was also blocking public access by default. So when we talk about evolution, I think we should zoom out just a little bit because we're talking about a change that is greater than just at AWS. And there's no time that this change is more apparent to me than when I'm considering the evolution of the security perimeter as a whole. Whereas historically, the hallmark of good enterprise security was defined primarily in the network layer using things like firewalls and access control lists. This has started to shift as the way that we work has started to shift. We now have more BYOD, we have IoT, we have geographically distributed teams, and increasingly, although network controls are still very important, please don't anybody at me on Blue Sky or Twitter, they're still very crucial. But they are a necessary but insufficient quantity. It's more of a yes and question rather than an either or. Increasingly, a good defense in depth strategy and zero trust strategy emphasizes controls that are at the identity layer, because identity is increasingly the determining factor for what types of resources and actions that people can take within your environment. Things like what type of group do they belong to, what is their job role, maybe where is their location or what time should they be accessing a particular service. And this means that we need to emphasize going forward really strong authentication as well as fine-grained authorization controls. Now, with this shift in the perimeter come some new risks to be vigilant about. Multiple industry sources have reported on a phenomenon over the past years since the onset of the COVID-19 pandemic, which we have observed as well. Attempted cyber incidents have only been increasing. And largely, those attacks are focusing on a core component of the identity perimeter, which is a user's credentials. For example, the 2024 Verizon data breach report found that of all the web application attacks that they assessed, which made up the majority of attacks that they assessed overall, 77% of those attacks deployed stolen credentials, and another 21% applied 77% stolen credentials, and 21% applied brute force techniques. All of this points us to the idea that we have a password problem. There are a lot of different problems with passwords. They are often weak, like the ones that are displayed here, and as much as I love my dog, I promise that's not my password, please don't go try it. They can be reused across websites often, which is especially a problem if one of those websites experiences a breach. Then your user's stolen credentials can be replayed and used elsewhere online, and they are of course phishable as well. Now, we do a lot to try to compensate for some of the weaknesses of passwords, and some of these are things that you guys might not be familiar with because we haven't really talked about them publicly before. But one of the things that we do is we monitor a variety of online sources to determine lists of weak passwords or ones that have been exposed in third-party data breaches. We then prevent our users from creating or updating root passwords using one of those impacted credentials. And if we determine that there has been a new data breach somewhere else online, and you are using a password that has been impacted, we'll require you to reset that password the next time that you log in and give an additional challenge for assurance to make sure that it's really you when you're doing so. The other thing that we do is we will issue, if we determine there's some kind of unusual activity on the account, we will sometimes issue a one-time PIN challenge to the email address of the root user. But despite all of these extra steps that we take to try to bolster password-based authentication, passwords just remain inherently vulnerable on their own. Fortunately, we have a simple and pretty elegant solution for password-based authentication, which is multi-factor authentication, or MFA. Now, I'm assuming that everybody here has at least maybe heard of MFA before, so I won't spend too much time dwelling on what it is, but just put very simply, it's a combination of different factors that you layer on top of your password, such as something that you know, like a PIN, something that you have, like a phone or a security key, or something that you are, which is also called inherence, which is like a biometric. It's an AWS IAM security best practice, owing to this exciting data point that we've found next to it, which is that we've determined that multi-factor authentication prevents upwards of 99% of password-related attacks, which are, again, among the most common types of attacks that we see. And best of all, we make MFA available at no additional cost at AWS. So we'll be talking a lot more about MFA and kind of this changing strategy around MFA and how you can impact your organizations at scale. But before we do so, I'm going to pass it over to Jason to talk about one of the exciting new features that we have for managing these devices and credentials.
Awesome. Thank you, Aaron. So let's take a quick look back before we start with this new feature. And back almost 20 years ago, this is what the login page for AWS looked like. In 2006, the world was a lot simpler. And so when you created an AWS account, you were given the option to create a username and password, and that became the username and password for what we call the root user on that account. And of course, as our customers' infrastructure complexity grew, we grew along with them. And so in 2011, a couple of years later, we introduced the Identity and Access Management Service. And so now customers could create multiple users, multiple roles, assign them various policies that could be scoped down, fine-grained permissions. And so this allowed customers to grow with their growing infrastructure and keep the security bar high for their cloud infrastructure. And this is the same IAM that you use today. But of course, if you look at a customer's cloud journey, right, over time, they're going to be adding more and more complexity, more and more compute. You may start with a single workload, let's say, that has a couple of compute nodes, maybe some storage, some S3 buckets. And as you grow that infrastructure, you grow that complexity, you'll add a couple of more workloads, maybe a few more accounts. And by the way, one of the best practices at AWS is using those account isolation features to help your security posture. And so customers really started adopting that best practice. And as they grew their infrastructure and grew the size of their cloud, then we see customers that have hundreds, maybe even thousands of AWS accounts spread out. And so now they need governance, compliance, et cetera, at scale. And so in 2017, we grew along with our customers and introduced AWS organizations. Many of you here in the audience probably use this. This, along with Control Tower, allowing you to create landing zones that have secure by default constructs. They allow you to centrally manage and govern all of your AWS accounts in one location. And again, it allows our customers to really take advantage of that secure by design account isolation that will improve your security posture. And each one of those accounts, though, still has its own associated root user. So echoes back into that original login page from 2006. If I look at an AWS organization and break it down one by one, it's now 2024. As Aaron mentioned, it's no longer sufficient to have a simple username and password for one of the most privileged or the most privileged user in your AWS account. So if you look at your AWS organization, each one of those accounts now has an associated MFA device with it. Here's a couple right there, right, that I took a picture of my desk. But each one of these, as I build out this organization, is going to have its own associated MFA device, and so on and so on. And as you can imagine, as our customers grow, some of our customers have 1,000, 2,000. When we started AWS organizations, you had a limit of 5,000. It's now grown to 10,000 accounts that you can manage within that tool. And some of our customers are getting up into those numbers. And so you can imagine if you're managing all of these accounts at scale, it can become very, very burdensome. But wait, I told you that back in 2011, we introduced this great feature called IAM. It allows you to create scope down policies and fine-grained access control for your users. So we still have this root user. What is it used for? Well, we took a look, and there's actually about, if you count it up, there's about 10 actions that only the root user can perform. And we talked to our customers, and essentially what we figured out was that if you bucketed those 10 or so actions by how frequently they are used, it really exists on a spectrum here. Well, we can take a look at, there's a couple things that you typically only do maybe once in your organization's lifetime, maybe once per account. You obviously need to close an account maybe once in a while, signing up for GovCloud if that's applicable to you, registering as a marketplace seller. Like, these are things that are going to be very, very infrequently performed. There's things a bit in the middle. You might want to change your account's name or the contact details, the email address associated with it. But what we found out was there's a couple of actions that our customers often took, and they needed the root user to do those actions. And I'm going to confess to you right here on the stage, I've done this. I've locked myself out of my S3 buckets. It's going to be a common occurrence, especially as you move that journey into least privilege. You're going to make mistakes, and that's okay. And so we've seen that if we can make this easier for our customers, let's go ahead and create something that will allow them to do that with less friction. So today I'm proud to announce that we have a new feature called Central Management for Root User Access. So this is a new mechanism that you can use with AWS organizations and Control Tower, so you can manage, secure, and control highly privileged access to your member accounts within your AWS organization. And it has two main components. First, you can centrally enable and disable root user credentials for your member AWS accounts. You can actually reduce your surface area for your accounts, because now, by enabling this feature and disabling the root user credentials for your member accounts, there is no way to log in as the root user. That root user is unavailable for those member accounts that you opt into this. And second, we provide a way for you to centrally perform certain privileged actions inside your member AWS accounts from a central location. And of course, we wrap all of this, like every AWS service, with a layer of audit and visibility. So you can take a look at your entire infrastructure at a glance and see what your state is where those accounts exist, where they do not. So let's step into the console and see what this looks like in practice. What you'll see when you log into your AWS organization's management account and open up the IAM console is a new tab on the left-hand side that says Root Access Management. If you click that, you'll get to this screen, and it's going to give you just this overview of what this feature means, a lot of what we're talking about today. But what you'll do, you'll click Enable, and it will bring you in here. And this allows you to enable one or the other of those two major features that I just mentioned. The ability to enable and disable root access credentials, and also the ability to take privileged actions, certain privileged actions, inside of member accounts. You don't have to enable both at a time. You could do one or the other. But I think once you experience this feature, you'll enable both, and you won't look back. The next thing that you'll want to do is figure out a delegated admin account. Really, it's best practice so that you don't log into your AWS organization's management account on a daily basis. So here you'll use maybe one of your existing delegated administrator accounts for security or other privileged accounts. You'll put that account ID in there. And that way you can use that account to take these actions instead of logging into your AWS organization's management account. And so once it's enabled, this is what we call at Amazon a two-way door. You can go in later. You can disable it if you wish. Again, I think once you experience this and once you see the reduction in your surface area, you're going to see a great value in this, and you won't look back. But you can see that you can disable, enable these features on a case-by-case basis, and you can change your delegated admin account later if you so choose. So let's take a look at each one of those three capabilities that I mentioned before. We'll start with the audit and visibility. So once you log in and you open up that IAM console, click Root Access Management after you've enabled the feature, you're going to be greeted with this. And this is going to give you an overview of your entire AWS organization, broken out by organizational units. And for each one of those accounts, it will tell you at a glance whether there is a root user credential enabled for that account or not. You'll see it on the right-hand side there. You'll see present for accounts where you are able to log in as a root user in some fashion. You will see not present with a green check mark for those where root user is entirely disabled. And if you actually hover over that and click on that present, it will tell you exactly what root user credentials are currently enabled. If you've got access keys enabled, if you've got credentials for a console login, signing certificates, MFA devices, et cetera. So you can tell at a glance what your security posture looks like across your organization. Let's say that you have a developer like me who made a mistake and has created and has locked themselves out of their S3 bucket through an overly restrictive S3 bucket policy. With this, you can log in to your delegated admin account, click through to take a privileged action in that target member account. You'll be greeted with this screen, and then you pick the S3 bucket that you'd like to remove the policy from. It will give you the policy. Right, so you can validate that, yes, this is the bucket, this is the policy. You click the button to go ahead and delete the bucket policy, and there you go. No more logging in as root, no more scrounging to find the person that has the root credentials, digging through to find the MFA device that you've used to secure your root account. You can do all of it from the console very, very simply. Let's say that for some reason, you do need to get into root, or in this case, we want to delete the root user credentials entirely. We'll see in a future slide what the state of your accounts look like, but when you start using this feature, of course, your accounts are in the state that they were before. They'll have the root user credentials that you started with. So you'll come in. You want to go ahead and delete the root user credentials for your member accounts. You can do that here through the console or through an API. And so here, if we go ahead and click through, we can see the delete root user credentials option. We can click into that, and then it will tell us the last time the console password was used, the last time access keys were used. We can go ahead and click the delete root user credentials, and what will happen is now that member account no longer has a root user. You cannot log in as root. There is no way to do it until you re-enable it through this feature. So what does this look like visually? So this is what you have today. Every one of your existing AWS member accounts either has root user credentials present, or a lot of you, the best practice, if you've got thousands and thousands of root users, have decided to create a random password and throw it away. So essentially, you have no idea how to get in, and you instead rely upon the root user account recovery mechanism to go ahead and create an account or create a new password when you do have to log in as root. So this is what your state looks like today. Now, what we've introduced with this new feature is this new state in the bottom right, and we think this is the best secure by default place you should be, which is now you have no root user credentials available in those member accounts. And the way you get to that state is very simple. We just saw it in the last slide. You log in into your delegated admin account. You click through. You find the member account you want to delete the root user credentials for. Click the button, and now you're in that great default, secure by default state. If at any point you need to take one of those actions that isn't covered by our policies to take some SQS or S3 bucket policy to delete those, you need to take some other root-only action, you can always re-enable it if you need to. At which point what happens is when you say enable or allow password recovery, you can then go through the password recovery mechanism, create a root user credential with a username and password, create an MFA device, log in as root, do the action, and then you can go through the cycle again to go ahead and remove the root user credentials. And I think the best part about this is now, when this is enabled, your new member accounts will be in this secure state by default. New member accounts in your AWS organization will be created with no root user credentials at all. Now, of course, all of this would be possible in the console, but it's way better for a lot of us when we're doing it at scale to script it out and use an API. So we have a new API called STS Assume Root. And what this allows you to do is it allows you to take those management actions using tightly scoped policies. You get a STS token that's time-bound, that's limited to that policy, and you can take that action. This is an example policy from the delete S3 bucket, for example, or S3 bucket policy. And of course, access is logged through AWS CloudTrail, and all that access is governed by your existing SCPs and resource control policies, another thing to learn about here at reInvent. So if we look at a very simple architecture, if you wanted to delegate this so that, let's say, your developers can use a chat interface through Slack or Teams or whatnot to automatically remediate their mistaken bucket policies, well, take a look at this. Maybe I have a user comes in through AWS Chatbot. There's a Lambda sitting in my delegated security account that it communicates with. It can communicate back into do an approval process, let's say, where I can have someone else approve that. Once that happens, the Lambda function then can call our new API, STS Assume Root. It gets back that time-limited credential scoped down just so that it can remove the bucket policy on that specific bucket. It can call in, change that bucket policy here to green, and then we can communicate back to the user that their remediation is complete. The best part about this feature, echoing Aaron's messages about secure by default and secure by design, is that this is available now globally at no extra cost. We feel it's very important, so we make sure we empower our customers with the best security at the lowest possible cost. So in conclusion on this feature, a couple of best practices. First off, go and enable it. Log into your AWS organization's management accounts, enable this feature for central management of root access control, delegate an account where you can take those actions from, of course, apply least privilege, remove all the unneeded root user credentials from your member accounts, scale it with automation, and then, of course, you still have one root user left, and that's the organization management account root user itself. So for that, I'm going to pass it back to Erin, and she's going to talk about how Amazon continues to raise the bar on MFA devices. Thank you.
Thank you. All right, thank you, Jason. So I would like to take just a second to say that while this is a very exciting feature because it can reduce any operational overhead and make it more efficient for those of you that are operating highly at scale, I'm personally most excited about this feature because it's a big win for security. You should absolutely use the new centralized root access management feature to reduce the number of reduce the surface areas and number of credentials that you have in your accounts overall. That will take care of any risks that you have to worry about for adding MFA to those credentials. It'll take care of if you have to currently rotate passwords due to some compliance regime. It'll address a lot of different concerns. But overall, we'll have fewer passwords in the ecosystem to worry about at all. But as Jason said, what passwords that you do retain, such as those on the management account root user or any member account root users that you choose to retain, they need to be protected. So we're going to circle back again to talk about MFA. So we support all the different leading industry standards for MFA. There is a flavor of MFA that should work for absolutely everybody. We support virtual authenticator apps, which are simply time-based one-time PIN, or I call it TOTP, although I don't think that pronunciation is caught on, but I enjoy it. That just generates an app code that you can use to sign in. A lot of customers really like these because they don't require you to acquire additional hardware to provision to your users. You can simply download an app to your mobile device, to your computer, and off you go. But if you do prefer to have some kind of hardware form factor, you can get that exact same thing in a hardware token. Last but not least is my favorite, which are FIDO2 passkeys. FIDO2 passkeys are the gold standard for authentication in this moment in the industry and our most highly recommended form of MFA for a couple of different reasons. They have some security properties that give them an edge over other types of MFA. They use public key infrastructure to create cryptographically secure key pairs that you use to log in. And they are domain bound, which is really incredibly important because it means that the credentials can only be used with a domain that was made to register them, which means they're phishing resistant. Now, historically, FIDO2 devices have been hardware-based. They've been security keys like YubiKeys, Talus keys, and then in later years, they started to be built into what we call platform authenticators, like Windows Hello, Apple Touch ID, other authenticators that are built in already to billions of devices around the globe. And then most recently, FIDO2 announced the release of passkeys, which are FIDO2 credentials that can be synced to the cloud, backed up, and restored. Has anybody here heard of passkeys before? Raise your hand. I'm seeing some nods. Okay, that's great. I'm really thrilled to hear that, actually. I work very closely with FIDO, and I think if I had given this talk a year and a half ago, we wouldn't have really seen any nods. So I think that speaks a lot to the work that the platforms have put in to make them more and more familiar every day. So we're going to zoom in a little bit on passkeys as the newest members of the AWS MFA family. I do get a lot of questions as people try to understand what are the changes between FIDO2 and passkeys. Or I'll even hear people say, should I use FIDO2 or should I use passkeys? But the great news is that you don't have to choose because FIDO2 or passkeys are just FIDO2. They retain many of the same fundamental security promises that you could expect from the hardware security keys, with the added benefit of, again, being able to be backed up, restored, and synced to other devices. They're still cryptographically secure, they're still domain bound, they're still phishing resistant, and some passkeys can actually still be device bound. Like if you use Windows, you can choose to create a device bound passkey if you want to have it centrally located only in that hardware. And they remain the gold standard for MFA. There are some things that changed about passkeys, though, with what we call syncable passkeys, so the ones that can be transferred between devices and onto your cloud. First and foremost, for many new people, FIDO2 just got usable for the first time. Now I use a hardware security key. I have one in my daily life to log into the various services and systems that we use at AWS. And if you can't see, I am actually wearing my YubiKey earrings today. And yes, they are the real YubiKeys. But for many people, not being able to rely on backing up that device and having access to it when you really need it was a bit of a deal breaker. I'm a very clumsy person, so if I'm back at home in New York and I drop my security key down a sewer grate and I don't have another one registered, that's it. I'm now in a very painful account recovery scenario, but that's not true with passkeys because I can simply use that credential that is stored to my iCloud or to my Google Password Manager, my Windows equivalent, and bootstrap a new device. This also helps with teams that are geographically distributed. You don't have to worry about waking up the security guard at 3 a.m. if you have some kind of break glass incident or, as Jason was alluding to, discovering that one MFA key that you might have registered to your root user. And with things like the credential exchange protocol, the portability is going to get even better for passkeys as you'll be able to port credentials between different providers. You don't have to worry about them being locked in, so to speak, to one provider or another. But one other important note before I move off from that is it is important to note this won't work for everybody's security model, right? If you have a security model that says it's actually really undesirable for someone to be able to back up a credential to their personal device or to sync it, then you may still want to look at the hardware form factors like YubiKeys, Talus keys. But for many people, this is where we finally find that right intersection between usability and security. So I know that a lot of you nodded your head to say that you were familiar with passkeys, but I'm going to do a quick demonstration just to show you how it works on AWS. It's very quick and easy. I'm going to show you 3 different flows from the passkey registration to the sign-in experience, and then a very special flow called cross-device authentication. So here I've got my username already on my root sign-in page. Thanks to Google Chrome, I have my complex password already saved and stored. And I'm going to be landing here on the console homepage where I just navigate up to the top right and I hit the security credentials drop down. The console is going to helpfully remind me that I don't have MFA registered since that's a best practice. So we're going to scroll down to where I can assign an MFA device. I'm going to give that passkey a nickname because I will hopefully have multiple different forms of MFA registered for resiliency. And then select passkey or security key. And next is going to pop up a browser window that asks me if I would like to save a passkey using Touch ID so I can just sign in with Touch ID. So I do that. I touch my Touch ID. And that is it. In a matter of seconds, I have materially improved the security posture of my account with strong, phishing-resistant multi-factor authentication. And then I'll quickly also show us just what the sign-in experience looks like with this. So again, I have my email address entered in. I'm going to click through and sign in with my password that's already saved and restored. It pops up and asks me if I want to use my passkey. I do. So I touch my Touch ID, and with a tap, I am into my account and proceeding onto the console. Now, you might be wondering, what happens if I don't have the device that I had saved a passkey to handy, or I've got a new laptop or something to that effect? There is a third flow called cross-device authentication, which you can use if you have any of the other devices in your possession that you have a passkey registered to. So let's say I have my iPhone handy and I have a Mac that I haven't registered a passkey to. So we'll see what that flow looks like. So I'm signing in just one more time. And then this pops up because I do have a passkey saved on this device, but you would see this next screen here if I did not, which gives me other options to sign in, including using a phone, a tablet, or a security key, which I'm going to click. And then up is going to pop a QR code, which I scan with my phone. And it's not just using a QR code, it also uses Bluetooth and proximity detection to make sure that I'm actually close to the passkey device. It's going to ask me on my phone if I want to sign in using that passkey and use Face ID, which is my preferred biometric on my iPhone. So I'm going to continue. It takes a quick scan of my face. And again, that's it, I'm in. Now, if I didn't already have a passkey saved on that demo device that I showed you, it would have also popped up and asked me, would I like to save a new passkey to that device? And that's going to work whether or not I'm using my iPhone with a Windows device, whether I'm using it with another Apple device. There's a lot of cross-device operability between operating systems and browsers that the platforms have been working very hard on over the past year. So I'm personally, as you can tell, a very big fan of FIDO2 authentication, but I want to take a moment to emphasize any MFA is always going to be better than no MFA at all. So if for some reason your organization just isn't ready to or can't adopt something like FIDO2 at this time, you're still going to be much better served using something like a virtual authenticator app than using password-based authentication alone. So why do we spend so much time on MFA today? Well, it's because it really is a foundational security best practice. We shared the data earlier that tells us how effective MFA really is. But despite this efficacy, across the industry, user opt-in to MFA remains really low and below where we'd like to see it, because this leads to entirely preventable account compromises with all of the business and human consequences that come with those compromises. So, in the course of our continuous evolution in the interest of secure by design, we took a look back at AWS and we decided last year that MFA is just too essential to be anything but the default experience on MFA going forward. We decided that it was time to make MFA required. But we were also very committed to this idea that we wanted this to be a positive change that we could bring people along for. We didn't want it to be disruptive to our customers. So we set out this program in phases, which I'll cover quickly, and you may get a sense of where your organization may be in this phase and in this part of this journey. So we started off by making an announcement. Steve Schmidt issued a blog post in October of 2023 that made the public statement that we were going to begin enforcing MFA and giving a high-level timeline for when this would start. And then on May 16th of 2024, this year, we actually began enforcing MFA for some root users in AWS organizations' management accounts. We started with the largest enterprises in our ecosystem. And then in June, as I said, we were very preoccupied with this notion that we wanted to bring people along in this change. And we anticipated that some of our users that are operating outside of organizations that may not be part of enterprises, they may be standalone accounts, individual developers, hobbyists, things like that, they may have a different index on which they value the security and usability trade-off. So we were very concerned about making sure that we had good, really, really user-friendly MFA options, and we took launching passkeys as second factor authentication as a dependency for expanding our program. So in June, at Reinforce, we announced that we had expanded the MFA program to include standalone accounts, as we announced the launch of FIDO2 passkeys as second factor authenticators. So if you haven't already opted in, because hopefully you're following our best practices to not sign into root very frequently, you may not have seen this page yet, but I wanted to give a quick glance of what that experience is actually like. So if your account is entered into enforcement, if you're in scope, the first time that you personally sign in, this isn't the same timeline for everyone, but the first time that you sign into that account, you'll get a notice that says, you don't have MFA on your account, MFA is required, please register. And it gives you the option to register right on the spot using any of the forms of MFA that we currently support. But again, we were worried about, would this be disruptive for somebody that maybe they don't access a root very often, they're doing so for a break glass kind of operation. So we included a grace period, which is currently 35 days. So you can skip this experience for up to 35 days. And at the end of that time period, you will need to add MFA to your account before you can proceed to the management root console with your root user. So we have some exciting data that we've been really heartened by in this program, and I wanted to share it in the interest of, if there's anyone in the audience that is seeing the same problem in your own ecosystem, you're looking at your own customer base and you're saying MFA would solve our problems, but we're worried about actually making this a requirement. The good news is that I think with a strong change management game plan and communication plan, you can also do this in a way that is non-disruptive and set your customers up for success. So between April and October alone, more than 750,000 customers newly enabled MFA. That's over 750,000 people that have a materially better security posture than they did before. And since we launched support for FIDO2 passkeys in June, we've seen a greater than 100% increase in the number of customers that are choosing FIDO2 based authentication. So not only are they more secure because they have MFA, they are using the strongest form of MFA that we have to offer in the industry today. But we're not quite done, and this next stage in the plan is really, really important. As I said, when we were planning our campaign, we were trying to understand what are the dependencies that our customers have that would really enable them to be successful, for this to not be disruptive, and that is why we prioritized releasing the central root access management feature before expanding the program further. We heard our customers when they told us that they needed additional tools to make it easier to manage these types of highly privileged credentials at scale. So now that we have the central root access management feature, starting in the spring of 2025, member accounts will also be required to have MFA if they have not used the central root management feature to delete the credentials from their account. So if you do that, which is the highly recommended path, by the way, this will be a much simpler mechanism than going through and adding MFA to the hundreds or thousands of member accounts that you may have. But if you choose to retain credentials on some of those accounts, they will be required to have MFA. So what are our takeaways for today? If you can't tell, I really don't like passwords. They are insecure on their own. We should not be using them as our only form of authentication any longer. You should absolutely use central root access management to reduce the total number of passwords that you have to manage in your environment and other types of credentials. MFA, for those that remain, is a very highly effective control to prevent unauthorized access. And there are some upcoming changes to MFA requirements at AWS that we should all be prepared for and tuning into now. If you have any questions for us about our session, we'll be available in the hallway afterwards. If you'd like to continue this discussion, we'd be happy to support that. That is our time for today. Thank you so much, and we hope to see you at Reinforce.